is Noorina Izzati and I want to present about vector analysis. Vector analysis is a branch of mathematics that deal with quantities that have both magnitude and direction. Some physical and geometric quantities called scalars can be fully defined by specifying their magnitude in suitable units of measure. Next point is vector algebra. A prototype of a vector is a directed line segment AB that can be thought to represent the displacement of a particle from its initial position A to a new position B. To distinguish vector from scalars, it is customary to denote vectors by boldface letters. Thus, the vector AB in figure 1 can be denoted by A and its length or magnitude by A. In many problems, the location of the initial point of a vector is immaterial, so that two vectors are regarded as equal if they have the same length and the same direction. My last point is calculus of vectors. A particle moving in three-dimensional space can be located at each instant of time t by a position vector r drawn from some fixed reference point O. Since the position of the terminal point of r depends on time, r is a vector function of t, its component in the direction of Cartesian x. Introduced at O are the coefficients of I, j, and k in the representation. The next slide is raster analysis. What is raster analysis? Raster analysis is the process of analyzing spatial information contained in grid dataset. Each cell in a grid contains a value or class which could be related to source, land cover, elevation, and another type of data. The next point is raster analysis tools technique. There are several raster processing techniques you can use to analyze your data. Here are some of the most popular: map algebra, zonal statistics, contours, map functions, and conditional. Next point is single layer analysis. Reclassifying or recoding a dataset is commonly one of the first steps undertaken during raster analysis. Reclassification is basically the single layer process of assigning a new class or range value to all pixels in the dataset based on their original values. These values could be simplified by aggregating each pixel value in a few discrete classes. The last point is multiple layer analysis. A raster dataset can also be clipped similar to a vector dataset. Here, the input raster is overlain by a vector polygon clip layer. The raster clip process results in a single raster that is identical to the input raster but shares the extent of the polygon clip layer.
Hi, my name is Zafira Amalia. So for my part, I will talk about point in polygon. So what is actually a point in polygon? A point in polygon is a special operation in which points from one feature's dataset are overlaid on the polygon of another to determine which points are contained within the polygon. To simplify, it is actually to figuring out if a point is inside a closed shape, which is a polygon, on a map. Imagine you have a map with regions outlined and you want to know if a specific location, which is a point, fall within one of those outlined areas. So next, let me explain more about this concept. Firstly is point. A point is a geographic point defined by its latitude and longitude coordinate. Next is polygon. A polygon is a geometric shape with a closed boundary formed by a set of interconnected straight line segments. And next is point in polygon. Point in polygon involves checking whether a given point is located inside or outside a specific polygon. Alright, this process involves various techniques to perform the point in polygon test, such as raycasting algorithm, which involves drawing a line, which is a ray, from the test point in any direction and count how many times it intersects with the polygon boundary. If the number of intersections is odd, then the point is inside the polygon, and if it's even, the point is outside. This operation is essential for tasks like finding which addresses are in a certain neighborhood or checking if a set of coordinates is within a boundary.
So hi, my name is Noorina Alia Batrisha. I will be continuing the presentation with my part, which is line in area and also area on area. So the first point that I want to talk is about line in area. Line in area is basically referred to the linear features such as road, river, pipeline, and other boundaries. So The analysis is often conducted by using the Geographic Information System, which is GIS, and has an application in fields such as survey and mapping, urban planning, infrastructure development. By using the spatial analysis technique such as buffer and also density mapping, we will understand the pattern and relationship that will impact all of this line on the surrounding environment. Basically, the line in area is often shown in the vector data rather than the raster data. So we will move on to the second part, which is area on area. Area on area involve the studying of the spatial relationship, pattern and interaction between different geographic areas. It also include the technique like overlay analysis, buffering, and also spatial statistics that understand how one area will influence or relate to the another areas. But this type of analysis is more valuable in urban planning and environmental management. So, geographic information systems are commonly used tool for conducting this analysis. In summary, area on area is basically the type of analysis is crucial for making informed decision in various fields, especially where understanding the interaction between different region is essential. So, what is basically GIS tool in this presentation is Geographic Information System will play a key role in the conducting spatial analysis, which is the GIS software allow us to integrate, visualize and also analyze the spatial data to derive the meaningful insight. So that's all for our presentation. Thank you so much.